YouTube, this is Salam. In this video I'm going to talk about the shielded metal arc welding, also known as arc welding or stick welding. If you are a beginner, this will be a good start for you, so please watch this video, and if you have any question, put it in the comment section and I'll do my best to answer your questions. Arc welding is one of the simplest way to weld two pieces of metal together or to do any kind of welding repair. It doesn't require shield gas cylinders, hoses, gauges, etc. You just need the welding machine, your safety gear, you hook one side of the welding lead to the work, you put the proper welding rod, start the arc, and you're good to go. I would like to share a few safety tips, especially if you are a beginner. You need to know about this to protect yourself and those around you. These welders, they designed to run on high current voltage. These two will run on 110 or 220 volt. This will run on 220 volt only. So make sure you work in dry environment. There is no water around, because water and electricity, they don't go well together. Also, make sure you don't drop anything on the cord of the welder, because it's high voltage, and if heavy piece of metal fell down, it will cut it and it will cause electrical hazard. I usually put the equipment, the welder, grinder on one side and do my work on the other side. This way I don't trip on wires, etc. You also need a good welding mask. I highly suggest you get an auto darkening mask. This way you could adjust the shade or the darkness to be able to see what you're doing. I'm not going to explain in detail about welding mask in this video. I'm planning to review this welding mask I bought off Amazon, and I will go in depth on how to set your auto darkening mask and how to use it to be able to see the welding pool. You also need a good welding gloves to protect your hand from melting metal, spatters, etc. You need to protect as much skin as possible wearing a cotton shirt or a weld jacket, and try to cover this area, because the weld mask doesn't go all the way down and you may get sunburn around your neck or this area. So be aware of that. You also need a good work boot that designed for welding. A good leather work boot is okay. It has a steel toe to protect your toes from anything falling down. Also make sure the work boot is rated for electrical hazard. It usually shows EH on the data tag of the boot, and this will help you not get electrocuted while you're welding. Sometimes if you're standing on the work, one side of the welding lead is connected to it, and then you try to put a welding rod in the rod holder. If you're not insulated electrically from it, then you get electrocuted. That's why a good electrical hazard boot is important for the job. I prefer to weld outdoor to minimize the exposure to the welding smoke, because sometimes it's toxic if you weld galvanized metal or metal that's contain chromium or other alloys. Stick to weld mild steel. Go to a steel yard and buy 2-inch flat stock, 1/4 inch thick, cut it to small pieces and practice weld with that. Don't just pick any type of scrap metal and start welding on it, because you don't know what it is. When you develop this skill, you could tell what kind of metal it is by doing a few technique to figure out the hardness of the metal, file it, etc. I'm not going to cover this in this video, because this video is only meant for beginner. Also, make sure to warn the people around you to not look directly at the arc, because this will harm their eyes. If you have pets, keep them away. If you weld indoors, the ray from the arc may reflect on the walls, so make sure if people are standing around you, even though they don't look directly at the arc, the reflection may damage their eyes. Be aware of that. Also, Arc welding will produce spatters and sparks, so make sure anything flammable, you keep it away. Gasoline, diesel, kerosene, dry hay, dry grass, these will catch fire very quick. So make sure when you weld away from those. As a beginner, you need to invest in good quality grinder. The grinder is very important. You have to clean the weld area before you weld. You need to actually clean it to the bare metal. For that, you need a grinding disc or a flat disc. If you don't have chop saw or bandsaw, you could use 6-inch cutting disc. They're very thin and they will cut easy. They're not designed to grind with. If you try to grind with them and apply force on them, they may break because they're not designed to work like this. They're designed to cut. So make sure you don't do that. And if you use the grinder, always wear a full face, a clear mask to protect your eyes and your face. Some welding masks, they have a grind feature. You press a button and the mask will not dark. You'll be able to see the work area while you're grinding. And then when you're ready to weld, you switch it back to weld mode and it will auto dark when you initiate the arc. You may ask what type of welder you should get as your first welder. I tell you my experience and you decide. The first 8 years with me start arc welding, I was using AC only machine. And I built stairways, spiral stairways, fences, gates, fixed implement for tractors, heavy equipment, etc. And it did great. Then I start use DC machine. In DC you have more control and the weld may look better in certain situation, and some rod they require DC only machine. If you could get a welder like this that capable of switching between AC and DC, it's great. This way you have the option. However, these welder, they use a lot of energy. They're not efficient. Some transformer based welder, they efficient, but those at the industrial level, they don't use something like this. They use either SCR to adjust the incoming voltage to the primary side of the transformer, or they use tabs, etc. However, this is not efficient. It uses more power than these two welders. Or you could buy something like this. I did a review on this welder. It's $120 something and it's been great. I have it for about a year and still weld okay. With DC welders, you have more option than just stick welding. You could get something like this. A spool gun. I bought this on eBay for $35 and I may show it in a future video. You could use it to weld the flux core and use it as mini MIG welder by connected to one of these welder. Or if you want to weld aluminum, you could buy you argon bottle, a flow gauge, hoses, and you need a 24 volt power supply and BWM motor regulator to adjust the speed, because there is a DC motor over here to adjust the travel of the wire, and you could weld aluminum. You could also use the DC machine to TIG weld. All the DC machines capable of TIG weld. You just need to get the right torch. You get a torch like this that has the valve built into it, and you could open the gas before you initiate the arc, and then you scratch, start, and you could, weld just like any other TIG welder. The only difference between this method and a welder or a modern welders that designed for TIG welding, the modern welders, they have high frequency start. You could start without touching the tungsten to the metal, and then when you get to the end of your weld, you could drop the current slowly, and then you could stop the arc while without doing this, and the end of the weld may not look pretty. With this, you could scratch start, come to the end, and then come off, or lift off, and the arc will stop, and you get TIG weld. I just thought to share this with you to help you decide which welder to get. There's a few things you could do to extend the life of your welder. All the three welders over here, they have fan to suck clean, cold air to cool the inside of these welders. If you stop welding and start grinding, make sure you turn them off so the fan doesn't suck grinder dust to put inside these welders. In the case of these two, they have electronic boards and the grinding dust contain metal particle and this will short the circuitry. In the case of this one, this has a thread inside to adjust a metal core, and this is how you adjust the setting. You don't want the grinder dust to get on the old thread, this will damage it. Also, you don't want this dust to be between the core and the transformer, and with time this rubbing action will damage and wear out the welder. Make sure you don't drop metal or anything on the lead, they're expensive and you don't want to replace them. Same thing with the power cord for them. I find through experience that regardless who manufacture the welder, for some reason they undersize these two and you find yourself you have to replace them. They cheap, if you go buy them online, they cheap. I did a review on a rod holder and actually it did very well. I welded a lot with it and it's good. It doesn't get hot and it holds the rod real good. So I bought two more to keep them as a spare. I may upgrade the one on the YESWELDER and the one on this one. These, they get weak in time, and if you weld a lot, it will get hot. And then the spring will get weak and it will not hold the rod good. So you may have to upgrade these. They cheap. This rod holder over here, you don't have to buy the same brand. Just buy one look like it and cheap. You know, the cheapest option to save you money. I think they manufactured by the same factory, but the people who sell them, they put their brand name on them. I don't know. This brand seems to be okay and it does good. So if you want to buy one, just watch that review. Other than that, if you just do this simple thing, your welder will last for a very long time. One of the job I had is winding motors and transformers. I actually built 3 welders. One of them was AC only, the other one I added diodes to it, an inductor, and made the other 2 into DC welders, or AC and DC welders. A lot of people, when they adjust the current, they weld and they have a helper to raise or lower the current. This is bad idea. You put a lot of stress on the thread and this will damage the thread or the bushing inside. Some AC and DC welder based on transformers, they have a switch. You could switch the current. Don't do that because the transformer is inductive load. And if you switch while there is load on the welder, this will damage the contacts of the switch. On this, it doesn't matter. However, I got to the habit of adjusting the current while I'm not welding. If I weld and I find the current set too high or too low, I stop and adjust accordingly. So don't adjust the current while you're welding because this may damage your welder. We all mistakenly call this the ground lead. This has nothing to do with the ground. This is just one side of the secondary transformer or of the IGBT, and it's not connected to the ground. None of these connected to the ground. I have the voltmeter set to ring on short circuit, and I'm connected to the YESWELDER. The ground is not connected to anything over here, or it would be shorted welder. You see, it has nothing to do with the ground. This over here is just one side to have different of potential between these two, so you can start arcing. This one over here, an electronic based welder, it's very important for the functionality. There's a lot of shielding inside to remove spikes and noise, etc. And it will drop it into the ground so the welder will function right. It also plays a big role into your safety. All of these welders, if there is any short, the heat sink in these two is connected to the ground, and the frame and the core, the metal core of the transformer connected to the ground. So if there is any short between the high voltage and the body of the welder, if it's not connected to the ground and you come and touch it, then you get electrocuted. That's why a good ground is very important for your safety. If it's your first time using a welder, before you plug it to the power, make sure you check the data tag for the welder and make sure it's rated for the voltage and how much current it's going to draw, and if it's rated for the proper frequency in your country. Also, one of the properties of the data tag is the duty cycle. For example, if they show this welder is rated a 20% duty cycle at 120 amp, that means if you're welding at 120 amp setting, you weld for 2 minutes and allow the welder to cool down for 8 minutes. If it show it's rated for 60% duty cycle, you could weld for 6 minutes and then allow the welder to cool for 4 minutes. And that's what duty cycle means. If you don't have 220 outlet and you're planning to hire somebody to install outlet for you, make sure you inform them that you need it for a welder. It's supposed to be rated for 50 amp and it's supposed to match these so they will fit in it. All the welder here in the United States, they have this male plug, so make sure the female plug, it will match this. Otherwise, they could install different type of 220 plug and it will not fit. Also, make sure they size everything accordingly so you don't have any problem with your electrical circuit in your house or in your shop. If you are planning to use extension cord, make sure you use heavy gauge wire. I highly suggest to have a 220 circuit for these welders. These welders, they're not only capable of arc welding. Any DC welding machine, you could convert it easily and use it as power supply, and you could add a spool gun to weld aluminum, or you could add scratch start TIG torch and you could TIG weld with it. You could do that with all these three machines. You just have to get a shield gas cylinder, gauge, hose connected to the torch or to the spool gun, and you're ready to go. With this method, you won't be able to weld aluminum. Aluminum required a TIG welder that's capable of producing square wave AC. None of these will do that. However, 220 is a very good idea because this welder will produce higher current and you could add additional stuff to it. One of the biggest challenge you'll have as a new welder is to initiate the arc. You're going to have the rod sticking. Don't be discouraged. This happened to everybody. When the rod is brand new, it's tapered at the end. This metal core, when it's touched the work, it will cause short circuit and it will start producing arc and heat and all that, and then the flux on the outside will start producing shielding gas and all that to protect the arc from oxygen and nitrogen and the atmosphere, etc. There is two methods to start the arc. The first one is the proper one, or the best method, is to scratch start or scratch the rod like a match. And you could achieve that by gently scratch the rod on the metal surface this way or sideways, and this will initiate the arc and you have minimum chance of the rod sticking. The second method, which I learned when I was a kid, nobody told me how to weld. I just saw a guy weld and he was, tabbing or stabbing the rod into the metal, and that's how he initiated the arc, and that's how I started. And I welded for a long time before somebody told me that you have to scratch, which it's die-hard situation for me right now. But I kind of learned on how to do it without get the rod to stick. And you achieve that by gently stabbing the rod into the metal. Don't jam it. If you jam it, it's going to stick every time. So tap it gently and the arc will start. Both methods, it's preferred if you start the arc before the beginning of the weld bead. And do it in the, where the two metal part that you want to weld, start ahead of the beginning of the weld, and then come to the beginning and then do your weld. This way the weld will look nice and the beginning of the weld will fuse good, and you don't have a cold spot where the beginning of the weld will have hump and the weld bead will look smooth all the way to the end. Learn the first method, however, practice with both. If you weld and then you have to stop and the rod is still good, you need to restart welding. If the rod is brand new, it will generate a cup at the end. And this cup will break easy, and you could restart the weld in both methods, either scratching or stabbing. Sometimes if the rod set in your garage for extended period of time, the flux will change its chemical components, if you will, and this cup will become hard, and it will not allow you to start the arc easy. And sometimes you find yourself you have to stab it harder or scratch it harder, and this causes the rod to stick. If you're near a concrete surface, just scratch the rod on the concrete, and this will cause it to break that cup, and you could restart the weld easy. Or you could hit it with a file. I kind of learned to just, tap it hard, and if the rod gets stuck, what I do, I disconnect the rod holder, wait a few seconds, 3 to 5 seconds, and this joint is very brittle. So if you wait 3 to 5 seconds after the rod gets stuck, you could do this and the rod will snap without you damaging the flux. After the rod get hot, then it will be okay to weld with it if it was damaged a little bit by moisture. Other than that, it's easy, straightforward. If the rod damaged for any reason, if you're welding and the rod got stuck and then you did this number and the flux came off, you could cut the metal core till where the flux is good by grinder or by alignment plier, a strong alignment plier. What I do, I keep piece of scrap metal and I hook the work clamp to it, and then I just do this number, scratch the rod, and this will burn the metal without the rod get stuck, because you do it very fast, you won't allow it to stick and you're going away from the arc. I will burn the metal till I get to the flux, and then I could restart weld easy. It's straightforward, it's not hard. You just have to practice more to get it dialed in, and you could weld easy without the rod get stuck to the metal. This is scratch and this is stabbing. A perfect weld bead, that means the current set correctly, you have good rod, your travel speed, the angle, the arc length, everything good. Then you're going to get good looking bead that's penetrated equally from the beginning till the end of the bead. This is sometimes hard to achieve. You could do it sitting in your shop, on a table, etc. But sometimes if you're in the field and there is wind, and you're not comfortable, you're standing on ladder, etc., you can't achieve that. Don't be discouraged. The purpose of weld is to fuse two pieces of metal together. So after you weld, if you clean the top surface and you find that the weld bead is fused to both parts, however the ripples is not spaced equally, etc., hit it with the grinder, flatten it out to the metal on both sides. If the weld look good and it look like you don't have porosity or any problem, then that's good enough. Carry on. Don't concentrate on try to make every bead is perfect, because this sometimes it's hard to achieve and it's unfeasible. The purpose for welding is to fuse two pieces of metal together. If you did that right, then carry on and don't worry about the cosmetic stuff. You could clean the weld, hit it with the grinder, and then paint it, and nobody can tell how the surface looked like before you painted it. Arc welding is the process in which an electrical arc is formed between the work and the end of the welding rod. When the electrical arc starts, it will immediately create a temperature of about 6,000 to 10,000 degrees Fahrenheit. This very high temperature will melt both the base metal and the end of the welding rod. The core metal of the welding rod at the contact point of the arc is melted into tiny molten droplets, and these molten droplets will be carried across the arc and mixed with the molten base metal. The force of the electrical arc and the travel motion of the welding rod causes the mixed molten metal to be pushed to the rear end of the welding pool, where it cools to form the welding bead. At the same time the metal inside the welding rod is melting, the coating on the welding rod, also known as the flux, is being consumed. The flux will melt slower than the metal core of the welding rod and will form a cup at the end of the welding rod, which shield the arc and help direct the flow of the molten metal droplets. When the flux melt, it will release shielding gas that cover the arc and prevents the oxygen and nitrogen in the air from mixing with the molten metal, and therefore prevent the formation of oxides and nitrites in the weld, as this will cause a problem and the weld joint will be weak. The flux contains chemicals. When mixed with the melting metal, will help to remove the impurities in the metal. These chemicals inside the flux, along with the impurities, will float to the top surface of the weld bead, form a slag over the bead. The slag also helps the molten metal to cool slowly to prevent the welding bead from cool too fast. And if this happens, the weld joint will be brittle and will break. Make sure you don't cool the weld area with water or blow compressed air, as this will cause a problem. Just allow the weld bead to cool naturally. Welding rods. There are many types of welding rods available to you. For the purpose of this video, I'm only going to show 6010, 6011, 6013, and 7018. However, there are many types. Once you become advanced welder, you could investigate what type of rod to use for a specific thing. There are rods designed to deposit more metal. There are rods designed, if you weld vertically, they designed to run downhill. There are other rods they designed to run uphill, depend on your situation. Don't judge the rod by the appearance of the top surface. Some rods, like the 6010 and 6011, they designed to penetrate deep into the metal. The top surface may not look smooth. The slag may stuck to the weld, and you have to remove it harder than other type of rods. That doesn't mean the weld is not good. As long as you don't have welding problems with the weld, which I will discuss later in this video, then your welding rod did its job, and if you use the two parts together. There are other rods like the 6013 will give you smooth top surface, however it doesn't penetrate deep. 7018 will give you a stronger weld and it doesn't penetrate deep. For that, I highly suggest to get 6011 and 7018. 6010, it will only run on DC current. 6011 will run on DC and on AC. So if you have AC only machine, you have to buy 6011. 6013, you could use it for both type of current. Same with the 7018. There are also other welding rods that designed to hard surface the metal, such as this one over here. If you want to weld aluminum with the stick weld, there are welding rods available for that. There are also welding rods designed specifically for cast iron, like this one over here. If you weld the stainless steel, you don't want the weld to rust, there are stainless steel rods. There are many rods available to you. The size of the rod will affect the end result. For this welder, I highly suggest to stick with 1/8 inch rod if you're welding on 220. You can go buy a rod designed to run on 250 amp and expect it to weld okay with the welder that's not going to produce more than 150 amp. So make sure you match the welding rod to the welder. You could step down, adjust the current setting by 1/16 of inch diameter rod. What that means is the diameter of the rod itself, the metal part. You could buy 1/16 diameter rod and you could weld thin sheet metal like 16 gauge. You could also weld it with the 3/32. 1/16 will be easier. You could weld easier and it will not burn through the metal. Because the bigger the diameter of the rod, the more current you need to adjust your welder to apply to the rod. There are a lot of useful information on the welding rod box. Make sure to read this information. This will give you an idea on current setting, polarity, and other useful information. I will talk about this later on in this video. The welding rod is represented by a number. If this number starts with an E, that stands for electrode. The first 2 digits of the number, they represent the minimum tensile strength. The third digit represents the position of the weld that this rod is capable of. The fourth digit represents the coating or the flux surrounding the metal core of the welding rod. I want to explain the term tensile strength for you. 6010, 6011, and 6013, they have a minimum tensile strength of 60,000 pounds per square inch. 7018, it has a minimum tensile strength of 70,000 pounds per square inch. What that means, you don't weld 1-inch bead and you expect it to withstand 60,000 pounds or 70,000 pounds. Because a lot of guys that I met, and when we start talking about it, that's what they think the tensile strength means. Let us imagine this is a square solid stock. It measures 1 inch by 1 inch. If I apply force or pulling force on it, On mild steel, it will take between 50,000 to 80,000 pounds to stretch this metal. That's why most welding rods for structural steel, they design between 60,000 to 80,000. So they will, or the weld will be as strong as the metal itself. Let us imagine we have 1 inch by 1 inch square stock and we want to splice it. And we bring another stock on the top of it like this. It also measures 1 inch by 1 inch. If I only weld it around like this, the weld will be the weak point of the setup. To make the weld as strong as the metal itself, you have to grind it and make a groove and weld it on both sides to make it as strong as the metal itself. Or even grind it as pyramid, and you have 2 points, they meet in the center, and then you fill all sides with weld, and you could grind it to make it look good, and this way it will be as strong as the metal itself. And that's what they mean by tensile strength. Weld position will also affect how the weld look. There is the flat position. If you bring 2 pieces together, I highly suggest if you're a beginner, just learn that. Then you have vertical weld. If you have 2 pieces you try to weld and they're going up, they call this the vertical weld. They also have the overhead weld when you try to weld something like this. And they also have the horizontal weld when you try to weld 2 pieces of metal, they horizontally. Practice with the flat position and then advance to the other position. You use same techniques, you just have to manipulate the rod little bit to get the desired result. Sometimes you find yourself in a situation where you have to weld vertically. For that, you will hear the terminology uphill or downhill. If you have to weld downhill, make sure you use fast freezing rod like 60-10, 60-11 or 80-10. If you only have 70-18, then you have to weld uphill because the way the metal hardened, it's slower in the 70-18 than the fast freezing rod, and that will cause, if you're going downhill and weld with 70-18, it will cause the melting metal to come down and then react with the arc and convert to spatter and fly everywhere, and you waste more of the rod fighting that than actually doing the weld. As general rule, if the rod support both direction, like 60-10, 60-11 or 80-10, you could weld in both direction. If you weld uphill, the weld will penetrate deeper and the weld may be a little bit thicker. If you're going downhill, the weld may look more aesthetically appealing, however it doesn't penetrate as deep. And that's the difference between both methods. The term polarity means whichever side of the welding leads the rod holder it's connected to. In the DC application, if the rod holder connected to the plus side, that means DC electrode positive. They show it for short DC EP, which means DC electrode positive. If for some reason the electrode requires DC negative, then you switch these, you put the electrode holder on the negative side and the work on the positive side. This will show as DC electrode negative or DC EN or DC negative. If you switch it to AC or if you have AC machine only, this really doesn't matter, because this one and this one, they will change polarity as the frequency, play. It's go on the positive side, and then in the second period of each hertz, it's go to the negative side, and the polarity, it has no effect on AC. On AC welding machine, don't get the AC sine wave confused with the square wave on TIG welders. On TIG welders, they have a machine that capable of producing square wave AC, so they'd be able to weld aluminum with the TIG welder. Don't get that confused with the sine wave. The AC stick welder, they actually step down a transformer that transform high voltage into low voltage with high current, so you could weld with it. That's what polarity all about. Arc length is the distance between the metal and the rod. When you initiate your arc, you need to maintain a minimum distance between the rod and the metal. You could actually lift the arc a little bit and it will maintain weld while the rod is above the metal. However, this produces undesirable weld, and it will cause a lot of metal to fly everywhere as a spatter, so you get undesirable weld. You need to maintain a minimum distance. When you start welding, a cup will form. The metal inside the rod will consume faster than the flux, and the flux around the core will generate a cup, so you could direct the weld. Sometimes you could rest this cup on the metal, and this will not affect the weld that bad. However, if you apply force, this is melting material and hot, so this cup will break easy, and then the rod will get stuck to the metal. So maintain a very minimum distance between the rod and the metal, and this will yield the best result, and you get good looking bead. Welding rods, they don't age very well. So make sure at the beginning buy welding rods in small containers. And make sure to protect the unused rod. Open the container, take the amount of rods that you need, and immediately close it. Try to protect the rods from moisture, especially 70-18. If they absorb moisture, then they won't weld good, and they will cause porosity when you use them. So always buy small container rods. If you buy large containers like 10 pounds or 50 pounds, make sure you pull out the amount of rods that you want to use, and then seal the container immediately and store it in a dry environment so they don't get any moisture and they go bad on you. You could repair old rods by put them in rod oven, and this will heat them up to a temperature. If there is any moisture on them, it will get out. I never use that. I always store them properly, or store the welding rod properly, so I never had problem with them. There are two angles that affect the performance of your rod. The first one is side to side angle. If I'm welding in the flat position, I need to maintain about 90 degrees at both sides. This way the weld will be uniform. The other angle is the traveling angle. When you travel with your rod, you need to maintain this angle. As general rule, the more steep the traveling angle, the more penetration. You don't want to get to the vertical position. You need to maintain about 80 degrees to 45 degrees. At 80 degrees, you're going to get the deepest penetration and more flat weld. At 45 degrees, if you're welding thin metal, then you weld at about 45 degrees. This will cause more deposit on top without penetrating into the metal. You have to practice. There is no one rule for all. You have to manipulate both angles if you weld a T-joint or something in the horizontal position or in the overhead. So you have to practice. Each welder will perform different and each condition is different. The thickness of the metal, the wind, how many degrees this joint is at. So you have to practice that. I can't tell you there is one rule fit all because there is none. There are many things that affect the end result of your weld. We're going to talk about them one by one. Current setting. I elected to show these three welders because all three of them capable of producing around 150 amp DC current. These two, you could change the current setting by adjusting the dial to go up or down. This one over here, you have to move this dial up or down to adjust the current setting. Some other welders, they have tabs. You just move the electrode holder to different tabs to produce different current. And some of them, they have big switch to select between 70 amp, 90 amp, etc. Each rod or electrode on the box is show the recommended setting. And this depends on the diameter of the rod. So go by the recommended setting. You try to stay in the middle. When you start to learn to weld, set the welder to the highest setting as recommended by that box for that diameter of rod. This way the weld will start easy. For that you need a thick piece of metal to practice on. A 1/4 inch, 3/8 or 1/2 inch thick piece of steel is sufficient enough to start to practice on. You will hear the term preheat and post-heat. While it's highly recommended to preheat the metal for any type of welding method, if you arc weld or MIG weld or TIG weld, etc., you have to preheat the metal. With 60-10, 60-11, 60-13, and 70-18, you don't have to. You could weld right away. Unless the weather is extremely cold or the metal is wet and you want to preheat it to remove any moisture that held on the surface or inside the weld joint. So you could have a successful weld. With arc weld, you could weld aluminum. The aluminum requires the preheat. You need to heat the aluminum till it reaches a certain temperature before you start weld. If you do that, make sure you get a gauge to measure the temperature of the surface, because with aluminum, if you overheat the metal, it will deform and you will have dip on the surface of the aluminum. The aluminum will, when it meets with oxygen, it will cause a crust, a very thin layer on the top of the aluminum, required more temperature to melt than the aluminum itself. So you have to make sure the aluminum reach that temperature before you start arc welding. When it's come to cast iron, you could also buy a cast iron rod to do any cast iron repair. For that, you have to preheat the metal to certain temperature. Keep checking it to make sure you reach that temperature. And then once you weld and finish weld, then you need to slowly drop the temperature so the cast iron doesn't crack. You can't cool it right away, or the cast iron will split and the weld, either the weld will crack or on the side between the bead and the cast iron itself. You could also weld the stainless steel. It's better to preheat the stainless steel a little bit. This will make the weld process go easy and smoother, and then when you grind the weld, it look uniform with the metal itself, and you can't tell this being welded if you polish it real good with the grinder. And with the stainless steel rod, the joint will not rust. You could weld the stainless steel with 70-18 or 60-13, however the joint will rust. So you have to use a stainless steel rod if you're welding stainless steel. And that's what preheat and post heat is all about. there is a relationship between the current setting of the welder, the metal thickness that you're welding, and the rod diameter. It tries to use a rod the same thickness as the metal you weld. So if you weld an 1/8" material, you could use an 1/8" rod or smaller. If you have thick material, then you could weld with really any size rod. However, try to use as big rod as your welder is capable to weld if you're welding thick metal. This way you don't have to run multiple beads and waste your time. You could run one bead and it will be thick and the weld will be strong enough. On thick metal, you could set the welder to the highest setting of the rod and you could weld and it will penetrate deep and your weld will be thick. On thin metal, you have to use a small diameter rod, set the current to the lower end of that rod, and then you could maintain the weld without penetrating through the metal. When you start laying beads, initiate your arc and just go straight. Don't do any weaving action, etc. You need to make sure to maintain a proper arc length, a proper rod angle, and proper traveling speed. Don't go too fast or don't go too slow. And this will give you a very good bead that fuse the metal real good, etc. Sometimes you need to fill a big joint and you need to put multi-layer bead. Lay one bead, remove the slag, clean it with the wire brush, then put a second bead and continue the process until you get to the desired thickness of the weld. Sometimes you have a situation where you have a groove that you want to fill. Do same technique. Fill the bottom, clean it, then fill on both sides until you fill it all the way to the top. Sometimes if you want to smooth the surface and you want to make sure there is no undercuts on both sides, you have to do a weaving action. You have to follow the same rules. You have to maintain a proper arc length, a proper travel speed, and a proper angle. And then you could do one in many ways. You could do a cursive E, or you could do moons, or you could just zigzag. You could do something like this. It's really up to you. Practice with all these different shapes. You will notice there is no big difference between all of them. After you finish the weld, you're going to have to grind it anyway. Once you grind it, then you can't tell what you used before to lay this bead. As long as it fused the metal together or fuse all these welding beads to smooth them, to make them look like one bead, then that's what you should be looking for. So practice with straight line without any manipulating to the rod, and then practice on the other methods after you master this one, because this is the base for everything else. If possible, connect the welder directly to the output plug, the nearest one to the circuit breaker. If you have to use extension cord, make sure you use big gauge wire. This way you don't suffer from voltage drop and it will affect the performance of the welder. When I built my shop, I ran 8 gauge wire all the way to the circuit breaker in the garage, so I don't suffer from voltage drop if I'm welding on 120 for stick welding or for flux core MIG welding. The 220 welder, I installed the plug directly under the circuit breaker, and I installed 50 amp circuit breaker, and I sized the wire accordingly. I run this extension cord all the way from the garage to the backyard to do welding with any of these welders on 220. So make sure you size your extension cord, if you have to use it, bigger than the rating current of the welder, so you don't suffer from voltage drop, and then the welder may not work correctly. The stopped arc welding is real easy. You have to be aware of a few challenges with any type of weld, not only with arc weld, with MIG weld, TIG weld, etc. When the metal gets hot, it will warp and twist. When you start weld, the metal deposit that you generate by the weld, it's at the steel at its liquid state, and it's expanded to the most. And when it's cooled down, it's going to shrink. So when you weld, you hold this piece vertical on the wall, and then you tack it. Then you find this piece of metal go this way. That's because the tack over here shrunk a little bit. So you have to take care of this. When you tack something, tack it on both sides. Don't weld right away after you tack the piece into multiple places in all directions. This may cause your weld to not look good because you have to go over these tabs. However, the most important thing about welding is not for your weld to look pretty. For the weld to be fused good, both parts join real well, and the weld bead is strong. You also want to achieve, if your weld has to be very strong, you have to get to the same thickness of the metal that you weld. If you have a half-inch stock and you want to weld two pieces together, then you want to make sure your weld bead at least half-inch thick to give you the same strength as the metal itself. You don't just put 1/8 inch thick bead and you expect this weld to be as strong as the metal. Other than this, sometimes you find yourself you have to weld little bit hardened metal to mild steel. Like you weld a spindle to a pipe to make an axle for a trailer. You have to keep the hardened metal cool by wrap it with wet rag. This way when the heat come to it, the heat will transfer to the water and it will evaporate. You need to keep the water away from the joint, because if water come to the joint, this may cause one of the welding problems that I'm going to cover later in this video. You may run into one or more of these problems. I'm going to talk about each problem and what you should do to solve each individual problem. Undercut. You weld. When you finish, you clean the slag, hit it with the wire brush, and you find the craters at both sides of the weld bead. Or sometimes if you weld a T-joint, you find the crater at the top of the bead. This could happen because the current set too high or you're not weaving the weld correctly. You may have to go faster and try to fill the top more, either by whipping action or E-cursive, but after the weld cool at the top, then you whip the rod fast to deposit more metal, and this will take care of it. I'm okay by having just little bit of undercut on both sides of the bead. That's okay. But if everything set correctly, if the current set correctly, your traveling speed and the angle of the rod, then you're not going to have undercut at all. But sometimes you're in a hurry, you try to weld something to get done, you will have little bit undercut. That's okay. As long as the metal is fused together, you don't have porosity, then you are good to go. Overlap. Sometime after you finish your welding bead and you clean it, you discover that the weld material is laying on the top of the metal. It didn't fuse to it. And this could happen because your rod angle is set wrong or the current set too low. So you could play with these two. Try to raise the rod angle more, or try to adjust your welder to higher current setting. Overlap is not desired. That means the weld joint is not good. You have to grind your weld until you see good diffusion, and then you may have to build a top bead on top of that to make sure both parts welded real good together and you have good diffusion. Porosity. After you finish your weld bead, you clean the slag, you find holes into the weld, and then if you grind it, the inside of the weld looks spongy or it looks like Swiss cheese. There's a lot of holes throughout the weld. This is not good weld. You have to grind the weld completely and start over. This could happen because the rod is too old. In the case of 7018, if it's absorbed moisture, it's not going to be a good rod. They put them in the oven. There's some special welding rod ovens to bake them to like 300 degrees, and this will let the moisture out of them. But sometimes if they set for too long, they may not be good anymore, especially if you start seeing rust and whatever on them. Just to throw them away and go buy new rods. Other time it happens if the arc length is too much. You're allowing oxygen and nitrogen to get into the arc, and this will mix with the melting metal and cause this holes. Or if you have water, if you try to weld and there is water underneath the metal or inside the joint, and then the water start evaporate and it will mix with the gases that release from the water will mix with the metal and will cause porosity. Sometimes if you set the current too high, you may get porosity at the beginning or the end of the welding bead. So you have to practice. But if you see porosity, you have to clean the weld joint all the way and start over. Sometimes you find yourself in a situation, everything is set correctly as far as the current setting on the welder. You already laid one bead and the bead look great, the metal fused together good, you look through your mask while you're welding, everything good. You still have a little bit left of the rod or brand new rod, and you know these rods is good, they brand new. And then you go to weld into the metal. I'm just using this to show you that the current will also go through the metal itself. You start welding on DC current and then you see the arc going away, and then to correct it, if you have DC machine, you have to manipulate the rod. You may have to set the rod at wrong angle, but it's doing its job right now. It's deposit the metal correctly. This is not your fault. This is called arc blow. The reason for it is magnetism. When the current flow from the welding lead to the work, to the metal, through the rod, this is right now a short circuit. If I take my clamp meter, I measure the current over here, or on the holder itself, on the rod, on the metal, on the clamp, it will read the same. There is high current going through it. This high current will generate a very strong magnetism, and it's going into a direction. You studied this in school. The arc is affected by that, and this magnetism will push the arc away. That's why you have to manipulate it. You finish the weld, you grind it, whatever, it fuse the metal together, however it doesn't look good. You could carry on with your life. If you have an AC welder, a welder that's capable of welding on AC current, and you have a rod that's designed to run on AC, because the rod that's designed to run on AC, it has a stabilizer in the flux to maintain the arc. So if you have an AC machine and you weld, you will not notice the arc blow. It's happened, but it's happened very little that doesn't affect the arc. In your country, if you have 50 hertz current, that means the current will change direction 100 times per second. So the current to flow or the magnetism will change direction 100 times, and this will make them fight each other, and it will not affect the weld arc as bad. If you have 60 hertz like here in the United States, the current will change direction 120 times per second, and this will even get better. So you will not be able to notice this arc blow, and your weld will look better if you're using the proper rod. I am going to weld with all three welders. I'm going to start with the Miller 150S, and then the YESWELDER 165, and then this Thunderbolt. They all capable of delivering about 150 amp. I'm going to check the output voltage. With the voltmeter, I'm going to check the current on all of them. I also going to check the input voltage and current using this tail end. I already tuned all 3 welders. I tried to weld on scrap piece and I set all of them to about 110 amps. I set this one to about 95 and this one over here to about 120. This one over here to about 107, 108 amp. The output is about 110 on all 3 of them. Each welder, I'm going to try to weld with the brand new welding rod, 8-inch 7018. They all set to DC positive.
The incoming voltage and the incoming frequency.
I will start with the Miller Max Star 150S. Now I'm checking the input current on this one. Now I'm going to weld with the YESWELDER. Now I'm going to weld with the YESWELDER. Now I'm checking the input current for the YESWELDER. And now with the Thunderbolt, it's bad weather to be welding. It's raining actually. That's why I'm under the shade. All transformer based welder will output high voltage when there is no load on the welder. This is called the open circuit voltage or OCV. This voltage should be less than 80 volt AC or DC to avoid electrical shock. Once the arc starts, the welder output voltage will drop to the welding voltage. And now I'm checking the input current of the Thunderbolt. the first two with the Miller Maxstar 150S, 3 and 4 with the YESWELDER 165, 5 and 6 with the Miller Thunderbolt. I just wish there is a physical way to make arc welding wirelessly like this. You don't need cables, you just need your rod holder and you could do the weld. That'd be a good idea. I covered all the basics about arc welding in this video. If I missed anything or if you have any questions, please leave them in the comment section and I'll do my best to answer your questions. I use the arc welding process in many of my projects. I will list these projects in the description section. Please watch whichever one you're interested in. I appreciate your support. Thank you for watching. Be safe and I'll see you later. Take care.